Good morning children. In this video, let's discuss some important chemical properties of metals. You know that metals are present on the earth crust. The reactivity of metals are different. Some metals are highly reactive, but some are moderately reactive. Some metals are less reactive. So in this video, I am presenting some important chemical reactions of metals. Let us consider the reaction of metals with the air. Reaction with air. You know that metals have metallic luster, that is shining appearance on their freshly cut surface. Some metals lose their luster immediately or easily. Metals like sodium. When we place a piece of freshly cut sodium metal in air, it readily loses its luster. Sodium is highly reactive. So it reacts with the components present in air, oxygen, moisture, carbon dioxide, and to form new product. As a result, it gets tarnished. Like sodium, magnesium also reacts with the air to form magnesium oxide. That is, magnesium reacts with the oxygen present in the air to form magnesium oxide. So as a result, the metallic luster of magnesium is also losing. And you know that aluminum vessels, they are losing their luster within a few days. Aluminum reacts with oxygen to form oxide layer. That is, metals react with the components present in air to form new products. As a result, they lose their metallic luster. But metals like gold, silver, platinum, they are not losing their luster because these are very less reactive metals. So they won't react with the atmospheric air. Then let us consider the next reaction, reaction of metals with the water. So the second reaction, reaction with water. Reaction with water. Certain metals react with the water to form hydrogen gas. The metals like sodium, potassium, calcium, they are highly reactive metals, so they can react with the cold water. When they react with this water to form hydrogen gas. So let us take sodium. When we place a piece of sodium in water, it runs on the surface of water and it disappears after some time. That is, it reacts with the water to form sodium hydroxide and hydrogen gas is released. Same way the potassium, it reacts with the water to form potassium hydroxide and hydrogen is released. But some metals, metals like magnesium, it required hot water to react. When it reacts with the hot water to produce hydrogen gas. And the metals like iron, iron reacts with the superheated steam, water in the form of steam, and produces hydrogen gas. But the metals like copper, silver, gold, platinum, there is no reaction with the water. That is, certain metals react with the water to form hydrogen gas. Now let us take the third reaction, reaction of metals with the acid. Reaction of metals with acid. You know that most of the metals react with the acid to produce hydrogen gas, especially with the hydrochloric acid. Let us take some examples. Zinc, the metal zinc, when it reacts with the hydrochloric acid, the products formed are zinc chloride. Its salt is produced along with the hydrogen gas is also released. Iron reacts with the hydrochloric acid to form iron chloride, FeCl2 plus hydrogen. Hydrogen gas is released. Magnesium reacts with the hydrochloric acid to form magnesium chloride plus hydrogen. That is, metals react with the dilute hydrochloric acid and hydrogen gas is released. But the metals like copper, silver, gold, platinum, there is no reaction even with the acid. They won't react with the dilute hydrochloric acid. These metals are inert metals, that is chemically inert. Then children, do you know what is meant by corrosion of metals? Corrosion of metals means the metals react with the components present in air, the components like oxygen, moisture, carbon dioxide present in the air, and form new products. This process is known as corrosion. You know that iron is a metal which is used extensively in our daily life. Iron is used in aircrafts. It is used in automobiles, used for the production of or making agricultural tools. In construction work, iron is used. The disadvantage of iron is it undergoes corrosion very fast. The corrosion of iron, it is known as rusting. And how is this rust formed? When a piece of iron is exposed in air, iron combined with the oxygen present in the air in the presence of moisture to form hydrated iron oxide, that is called rust. Rust is chemically hydrated iron oxide. Iron reacts with the oxygen present in the air in the presence of moisture to form iron oxide, hydrated iron oxide. See, let us consider an activity. Let us see which are the factors that favor the rusting of iron. For that, let us consider an activity. Take 4 polished iron nails and keep these iron nails in the different situation. We are keeping the iron nail, first we are keeping the iron nail in wet cotton. That is, place a wet cotton in a test tube and place this iron nail. And in the second situation, that is, we are taking some calcium oxide in a test tube and we are placing this iron nail in calcium oxide and the test tube is closed. This test tube is closed. And in the third case, we are keeping this iron nail in sodium chloride solution, NaCl solution, that is half of the nail is outside the solution, so it is kept like this. And in the fourth case, the iron nail we are keeping in dilute hydrochloric acid. The nail, it is kept in dilute, half of the portion outside the solution. So these are the different situations we kept these iron nails. So let us see, observe these situations or observe these test tubes after a week. We can see that in some test tubes the iron nail got rusted. In which all test tubes iron nail got rusted? In the first test tube, third and fourth. That is, here it is kept in wet cotton. So it reacts with the oxygen, in the presence of moisture is also there. So rusting takes place. And in the second one, it is sodium chloride solution. And here also rusting takes place. In dilute hydrochloric acid, there also rusting takes place. And in which test tube the reaction is vigorous reaction? In the third and fourth test tube, it is a vigorous reaction. In the presence of salt as well as acid, rusting of iron is very fast. So there rusting takes place very vigorously. And what about in the second test tube? The iron nail is placed in calcium oxide, quicklime. What is the peculiarity of quicklime? It is a drying agent. Calcium oxide is a drying agent. Drying agent means it can, the substance that can absorb water. So when we are keeping iron nail in calcium oxide, the moisture present in the test tube, it is absorbed by calcium oxide. So all the moisture is absorbed by calcium oxide. So there is no moisture in the test tube. So rusting won't take place in the absence of moisture. So iron won't rust in second test tube. So which are the factors that affect the rusting of iron or that favor rusting of iron? Moisture is a factor. Moisture is a factor. When the temperature increases, rusting, the rate of rusting also increases. So temperature is another factor. Temperature is a factor, isn't it? The presence of salt If the moisture is salty, rusting is very fast. So, presence of salt as well as the presence of acid, it also enhances rusting of iron. And do you notice that in coastal areas, the window bars of houses near coastal areas rust very soon, rusting is very fast. What is the reason? In coastal area, the atmosphere consists of salty moisture. So, if the moisture is salty, rusting is so fast. That is the reason in coastal area, the iron bars, the window bars, they rust very easily. Then let us see how can you prevent corrosion of iron. What are the methods used to prevent corrosion of iron? Yeah, usually we are using the method that is by painting. By painting we can, that is prevention of corrosion. By painting we can prevent corrosion of iron. Then by applying grease and oil, by applying grease and oil we can prevent corrosion of iron. Then galvanization is another method used to prevent corrosion. What is meant by galvanization? Coating zinc on iron, that process is known as galvanization. So, by coating zinc on iron we can prevent corrosion. Then electroplating is another method. Through electroplating, that is plating a metal on another metal through electrolysis. So, iron can be protected by electroplating. Usually chromium is used to plate on iron. Then converting into alloys, alloying. By converting into alloys we can prevent corrosion, which is the alloy of iron. Steel, converting iron into steel we can prevent corrosion of iron. So, these are the different methods usually used to prevent corrosion of iron. So, these are some important chemical properties of metals. Thank you.